This is our first video on power. Use English words to write two equations for average power. Average power is work divided by time. That's one equation for power. Another equation might be energy transferred per time. Energy transferred per time. If we use calculus type variables to write two equations for the power at any instant, the power at any instant is the tiny amount of work that's done divided by the tiny amount of time that has elapsed. Another way we could write it in another context, perhaps it's the tiny change in energy divided by the tiny time that has elapsed in between that change. And hopefully, at least this equation on the left, that might go along with an equation you are familiar with from earlier studies in physics, and that is that power is work divided by time. And sometimes we write, hey, work is force times distance. So we could change that numerator to force times distance divided by time. And then look how clever this is. Distance divided by time is speed. And so sometimes we can calculate power taking the net force multiplied by the speed. But you can see here, especially with that one where I'm drawing an arrow, that is equivalent to this expression right here. And since work and energy have the same unit, we can talk about power as being work per time. We can also talk it as being energy per time. Power is going to have what unit? Well, it'll have the unit for work, which is joules, divided by the unit for time, which is seconds. And a joule per second is a watt, which is symbolized by a capital W. So you want to be careful here because we've got two capital W's. We've got this one over here, which is the unit for power, capital W. And then we have this one right here, which is the variable symbol for work. So just be very careful when this kind of thing comes up. Let's try a couple of examples. Suppose we have this graph here, and we want to use the graph to determine the power being expended at any instant between t equals 0 seconds and t equals 6 seconds. There are any number of ways we could do this, but we might remember that power has the unit joules per second. So if we look at this graph, we have joules on the vertical axis, we have seconds on the horizontal axis. Joules per second, rise over run. That's what we're looking for here, aren't we? We can find the power if we find the slope here, and that's going to easily be done. 90 divided by 6 is going to be 15 watts. How about one more graph? Let's use this graph. It looks the same, but it's not quite. Let's use this graph to find the work done between t equals 1 second and t equals 4 seconds. Well, what's work? Work is joules. And let's see. So work is joules. And what do I have in this graph? I have, on the vertical axis, I have watts, which is joules per second. And on the horizontal axis, I have seconds. So I can see that I need to multiply these two in order to get the unit joules. And when we multiply these two on this graph, doesn't that mean we're going to need to find the area? Specifically here between 1 second and 4 seconds. So I'm going to go ahead and hatch that in. That is the area that we want. So the area is going to be the average of the parallel sides. So this one is 50 and that one is 200. And then multiply by the width, which is 3. And we do that in our head. That's 250 divided by 2, that's 125. 375, 375. And what's the unit for work? Joules.